Welcome to the Job Shop Show, where we talk with the owners, suppliers, partners, and customers of custom manufacturers. Listen and learn the secrets of top-performing job shops, the tools, techniques, and backgrounds that have made them successful, all in the quest of raising the bar for custom manufacturing. I'm your host, Jay Jacobs. This episode is sponsored by Paperless Parts, connecting buyers and suppliers of custom manufactured parts. The Paperless platform is a secure, ITAR-compliant, cloud-based manufacturing system for suppliers that reduces the amount of time spent on sales, estimating, quoting, administration, and order processing. It offers seamless integration with the accounting and ERP software tools that shops already use, such as QuickBooks, E2, and JobBoss. Paperless Parts was founded with a mission to make manufacturing more accessible by streamlining the quote-to-cash process. Spend less time quoting and more time selling.
This episode is sponsored by our friends at the NTMA, the National Tooling and Machining Association. The NTMA is an association of privately held, entrepreneurial-based, and family-owned businesses, representing nearly 1,200 small to mid-sized machine shops and tool and die shops across the country. They have approximately 30 very active regional chapters that host local events, run apprenticeship programs, and provide other services to their regional members. As an association of peers, the goal of the NTMA is to help members of the U.S. precision custom manufacturing industry achieve profitable growth and business success in a global economy through networking, workforce development and training, technology, best practices education, advocacy, programs, and services with industry partners. To learn how your company can get involved with the NTMA, including how to join, visit ntma.org.
Shazam! This is Jay Jacobs. Welcome to the Job Shop Show. Today, we are going to talk about one of those areas in custom manufacturing that has always been a mystery to me. No, it is not why there are the same number of women's toilets as men's in the shop. It is welding. Our guest is Roy Crumrine, also known as Crummy, of Crummy Welding in Lebanon, Ohio. Roy is a crackerjack welder, and he is so into welding that he and a couple friends host a podcast about welding tips and tricks, a very successful podcast with tens of thousands of downloads and over 200 episodes. If you want to get into the exacting details of welding, this podcast is a great resource. However, I want to approach our conversation today from the owner perspective. Welding was a big part of Rapid, but I didn't really understand it and never got into the details. Perhaps there were things that I should have known that would have helped us be a better supplier to our customers and made the whole welding team members' lives much easier. Extracting these insights and just getting into the basics of welding is the goal today. So let's get going. Welcome to the Job Shop Show, Roy.
Great. Thanks for having me on here. I'm looking forward to it.
Yeah, me too. I am fascinated. So I want to start with the podcast. Your podcast about welding, it's gained such a large audience. How did you start the podcast and why?
Well, we do the podcast. It's with Jody Collier with Welding Tips and Tricks. If you don't know him, look him up on YouTube. He's got a huge following on YouTube, and he's basically the godfather of welding when it comes to teaching and training on YouTube. And I met him in, I believe, 2011 at an air show of all places. And we started talking, became friends. And then several years later, we were talking about doing a little bit of, collaborating together. And I just mentioned to him like, hey, why don't we kind of do a podcast? There's really not any welding podcasts out there. So let's do it. So we have me, Jody, and then another friend, Jonathan Lewis. He's with Superior Welding. We have a very broad experience when it comes to welding. Like Jonathan's into the really big, heavy duty Mig Welding. I'm into the really small, finite, really, really small detailed welding. And Jody was more into the aerospace and training and stuff like that, where he worked with Delta for a very long time and did things. So we have a wide range of experience to pull from when we talk in our episodes. And when we started about it, we all kind of basically nerd out about welding all the time. So it was like, well, why don't we just record the conversations we're having and go from there and see what happens. weren't sure if it was really going to take off, but it actually has. And we have, like you said, a very big following. And it's been a lot of fun. We've been doing it for several years. And we just recently posted episode 220 as of recording this.
Wow.
And it's been a lot of fun.
Yeah. My journey to this podcast was somewhat similar, although I'm doing it solo, but I was having conversations with owners and I just thought I should be capturing these because there's some nuggets that every owner and person I spoke with, there's something that other shop owners and other folks working in custom manufacturing could take away. So,
Yeah.
and you guys have just hit a home run with yours. So congratulations there.
Thank you. And one of the other things we really wanted to do was to be able to share our stories and have other people share their stories and be able to, help guide new people into the industry and help people that have been in the industry for a while, maybe get into a new trade or, get a new job or whatever, just learn new stuff. And it's like we said, it's been a lot of fun and we don't plan on stopping it anytime soon.
Good. I think with the downloads that obviously there is a audience that wants you to continue going. Let's step back. When did you decide you wanted to be a welder and how did you get into it?
Well, I was probably about 12 years old or so, and I was really into trains and railroads and stuff. And I remember going to one of the big yards over in Tampa, Florida, where I lived. And I saw these guys coming out of one of the repair shops and all the sparks flying and cutting and stuff like that and loud noises. And I was like, that looks really cool. And I'm like, I kind of want to do that. That seems like right up my alley. And several years down the road, it came time to where it's like, all right, well, I need to get a better job than the one I've got. And at the time, my future father-in-law, he was a superintendent for a construction company. And he said, he's like, well, if you want to get into welding, I can get you into a company. And so he took me around to actually 3 different companies. One was like a handrail company and then a structural steel company, 2 structural companies. And he's like, take your pick of which ones of these want, and I'll talk to the boss and see if I can get you in. And he kind of steered me more towards the nicer, cleaner shop. It's like, this is kind of the one you want to go to though. So I ended up going to that. And that's where I started to learn how to weld. I didn't go to school. I didn't have any formal training or anything. It was just on the job training. And I've bit-bopped around in many different industries and just asked loads and loads of questions in every place that I've worked, learned from the good people, learned from the bad people, and it's where I am today.
When you started, what did day one look like when they started you in that welding department? What did they do to start training you since you didn't have any schooling?
They handed me a grinder. They said, here's a grinder, go out, grind these big I-beams, make sure all this flame cut is nice and smooth. And then when you're done with that, go grind these welds. And for probably the first 6 months or so, that's what I did, was just grinding. I had to pay my dues, I guess you could say. But at the same time, I personally can't stand grinding. I don't like doing it at all. But
So you did pay your dues.
Yeah, definitely did. But it helped me in the long run, I believe, because if you've got a really nice, smooth, good weld, it grinds off very nice and easy and it's faster. If you've got a fast, bumpy, globby weld, well, now the guy that's grinding it's got to sit there and, take twice as long to make it look decent. And then it probably isn't as strong. So it really kind of beat into my head and taught me to take the time and do it right and lay down a really nice, smooth weld that's going to be easy to grind off. And if you don't have to grind it off, it looks great. So, I always go back to my time. Would I want to grind this weld off? Or if I left it, would I be proud of it? And that's where I'm kind of thankful I started as a grinder and worked my way up from there.
How many welders in the shop did they have so that you saw different people's welds, as well as would you see the same welder have differentiations in the weld that you had to grind off? Because I
Oh
always
yeah.
think about coming in on maybe a Friday morning if somebody has been out the night before. In so many areas, you can definitely tell the difference in quality of work. Does it apply to the welding, for instance?
Oh yeah. I always say your welding is your handwriting. You
Mm-hmm.
know, the bead that you lay down, it is your handwriting. You can really tell once you start paying attention and you start knowing who you're working with. You can tell just by looking at it who welded it. And there was one place I worked at in Phoenix that we actually made vacuum chambers, and it was all inside of a clean room. And it was the only place that they had a copy exact rule or something where everybody kind of had to make their welds look the same.
Mm.
So that was a little different, and you still could tell who welded what just by where the stops and starts were, because there was a production shop, so everything was the same parts over and over again.
Mm.
But it was challenging because those guys were really good welders, so it kind of upped your game a little bit to, you know, become as good as they are. And then eventually you're like, did I do this one? It's like, no, my stop is over here, so nope, that's not mine, you know. And it was kind of fun when you could be up with those other guys.
We're going to detour a little bit into a couple things you said, but I want to get back into the basics of welding. But let's dive into you starts and stops.
Hmm.
Talk about those a little bit. Why someone would start and stop, and how they are different from welder to welder.
Well, it depends on the process of welding that you're doing. If you're, you know, say you're doing stick welding, you only can go about, you know, 6 to 7 inches per rod. And then you have to stop and grab
Mhm.
another rod and start up again. If you're MIG welding, a lot of it has to do with
If
comfort.
you, sorry to interrupt, if you're stick
Mhm.
welding, then if somebody is being, I guess, efficient with the stick, would they go longer? And that's part of the differentiation between the start and the stop. I'm trying to figure out how you recognize the start and stop difference between welders.
With stick, now I don't have a whole lot of experience with actual stick welding. I'm
Okay.
more of a MIG and TIG, but the rod will only burn for so long because it's only, you know, such a long rod, and it'll burn for so long and then it consumes away. So, you know, you can only, like I said, you can only get about 6 inches of weld if you're doing, you know, to get the size of weld that you're looking for. If you're going longer, then you're probably putting down a smaller weld because it's
Hmm.
stretching it out a little bit.
Hmm.
um, but like I was saying, with MIG welding, a lot of it has to do with comfort. If you can make the whole run in one pass without burning your knuckles up or catching yourself on fire or whatever, you know, and then speeds and settings and stuff like that change things. But and with same with TIG welding, a lot of it has to do with the length of filler wire you're using. You can only go so far, how far you can go before you are not comfortable anymore. Because one of the big ABCs of welding is always be comfortable. And so that's where, if you're left-handed or right-handed, you know, if you're with TIG welding, if you can kind of see the dimes that you're in down, if you're right-handed, they go one way. If you're left-handed, they go the other way. So that's a big
Mm.
thing
Sure.
if you're a southpaw.
And you mentioned the grinding. You could add time depending upon how the weld was laid down. Can it literally take twice as long to
Oh yeah.
grind?
Yeah, if
So so as an owner, I don't want that. I want to be
yeah.
able to predict the time that it's going to take to grind. And if I have variation in the weld, then I'm going to have variation in grind time, and that's potentially going to cost me money.
Oh yeah. If you say, like, I worked in a sheet metal shop where they did a lot of grinding
Hmm.
there, and you know, if you lay a really nice smooth weld and it has to be radiused over with a grinder, you could just kind of zip 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 and it's almost done
Hmm.
if it's if it's welded properly. But if you don't take the time and do it right, and it's all bumpy and globby and there's porosity, which is little pit holes in your weld
Hmm.
and things like that, then you got to grind all those bumps down to smooth all that out, and then grind any low spots and come back and fill those back up and bring it back. And there's a lot of back and forth where if you just took the time and did it right the first time, you're good to go.
And the porosity, is that related to the strength of the weld that you mentioned?
The porosity is related to contamination in the weld. So if there's a lot of porosity in the weld, yeah, it will drastically affect the strength of the weld.
How do you get the contamination?
That would be not, there's stuff like a mill scale that's on top of the material,
Mhm.
poor gas coverage, just anything that is a foreign object on the material. You want to have the material to be as clean as possible.
Mhm.
You know, if you can get it to bright, shiny metal on all surfaces that are going to be welded, that's ideal. Any oils that might be left on the part, like if it's a machine shop part and there's cutting fluid that's been dried on there for like a week because it's
Mhm.
been sitting on a shelf before it got to you, and then you don't have the time to wipe it all off and you just weld over it, that
Mhm.
can cause a lot of problems.
So if porosity is visible, then questions should be asked what's going on in the process.
Oh, absolutely.
Hmm. Okay.
Even
I remember seeing porosity, but I didn't know that it's something that could be prevented
oh
if
yeah.
I just assumed it was part of the natural welding process, and sometimes it was there and sometimes it wasn't. And this is great, Roy, because these are the types of things for a owner who's not operations focused, and I was sales focused, but those are the types of things that add costs in your shop and ultimately raise the price for your customers or make you less competitive and possibly give them an inferior product or one that not as good as they could be getting. This is great.
Yeah. And even down to the, if you have a laser in your company
Hmm.
and you're doing, sheet metal company, and you're cutting your parts with a laser, and you have that, you're doing just regular mild steel, and you have that black or kind of like a bluish burn
Hmm.
on the edge. That needs to be ground off. Just a quick zip with
Mm.
like a 90 air grinder. Just take that off and bright shiny metal, and your welds will be, you know, at least 50% better than it was with that, because that burn on there is considered a contamination,
Hmm.
and that will cause porosity, that'll cause problems.
Mm.
So if you just take the 2 minutes and zip that off, it'll save you so much time in the long run. Again, going back to the grinding process, or the after, your welds will be a lot smoother, it'll look a lot nicer, it'll weld a whole lot nicer, so the welder will be actually happy because they laid down a nice weld. And this is mainly for TIG welding too. It does help for MIG, but for TIG it's very, very important to have that clean material to work with.
I love these details, and we're going to get back into them, but I want to continue your journey. You put in your dues, then how did the actual welding start?
The actual welding started when I was at that first job, and I was watching a bunch of the guys welding, and they're all MIG welding structural stuff and handrails and beams and things along those lines. There was a structural side, and then there was an aluminum handrail side.
Hmm.
And I was watching them and just kind of like, is that all? That's how you do it? Make the little whip and pause and go. And they're like, yep. One, I would pick it up over my lunch break, sacrifice my lunch break and just, start welding on some scrap pieces.
Hmm.
And one day I laid down a pretty good weld, and my boss came over and looked at it, and he was like, "You did that?" And I said, "Yeah." And he goes, "Okay, well, can you build this?" And he gave me a print, and I know I had taken blueprint reading and drafting in high school. So
Hmm.
I knew how to read prints, basically knew how to read them, and built a small gate. And then I was off to the running from there.
What is a gate?
Just like a regular fence gate.
Oh, okay. So the product, a gate.
Yeah.
Gotcha. Gotcha. I thought it was some fancy
No,
welding jargon I had never
no,
heard
no,
of.
just a regular gate,
Made a gate.
and that
Cool.
was a small project that they trusted me to do for my first one. And they said, if you could build this, then we'll talk about you being more of a welder instead of a grinder. So I was like, I'm going to get this right.
Hmm. Excellent. Well, you learned, and it sounds like it was more MIG, and maybe this is a good time to give us some of the welding 101. What's the difference between MIG and TIG, and where do you use one versus the other, and maybe types of metals?
Well, MIG welding is what you see in a lot of like big production shops, where there's a big spool of wire that's on the machine. The wire comes out of the gun, you pull a trigger, and it it comes out and it sprays, and it's a lot of steel. There is some aluminum you can do with it. You can really MIG a lot of materials, but you just change the wire and change the settings and the gas at sometimes too. But it's more for bigger things, bigger products, bigger shops, not necessarily bigger shops, but just bigger products.
Mm-hmm.
And TIG welding is more for more finite, detailed welding, like on aluminum or titaniums and stainlesses and stuff like that. If you want a real small weld that's pretty strong and nice and clean, there's no splatter and stuff to clean up. It's very particular when it comes to being, in a clean shop, clean environment and all. And that's where you hold a torch in your hand and you feed the wire. Most of the time you feed the wire by the other hand, and you run it with a foot pedal or a switch on the torch itself. So I always kind of equate it to like flying a helicopter, where every appendage is kind of doing its own thing.
You ever flown a helicopter?
No, I would love to, but I haven't.
You have some beautiful weldments on Instagram, and you have become a very accomplished welder yourself. And the characteristics, I guess, of your welding are distinct enough that other folks can recognize Crummy Welding. How did you get to this point, get that finesse in your welding from that first weldment of a gate?
Well, a lot of it, I honestly think it's because I really, really enjoy it, and I'm always looking to improve. I've never laid a perfect weld, and I never will lay a perfect weld, but I'm always striving to lay that perfect weld. And if there's anything that I can do to up my game by, changing cup sizes or changing gas flows and, just never settling on, that's good enough. It's always, well, what can I do to make it just that much better? Trying to never skip a step of, maybe I should wipe this down. Maybe I should do this. Nah, I don't have time to do that. It's like, no, take the time, wipe the parts down with acetone or methanol or whatever you can clean off the parts with. Don't use brake cleaner. And that can be bad. A lot of people use brake cleaner, but I'm just saying, don't use brake cleaner.
Don't use brake cleaner.
But just taking the time to do all the steps and never being happy with, like, that's really good, but how can I make it better? And always paying attention to the smallest details I can possibly can.
How did you learn what those steps were, though, when you were starting out?
Well, a lot of it was, like I said, you learn, even if you work in a bad shop and they're doing bad things, you still learn from that. You learn, well, I don't like how this is coming out. And then a lot of it has to do with, because they're not cleaning the parts, or they're not wiping these parts down, or they're spraying the saw with this cutting fluid of some kind, and we're welding over it, and so you learn, like, I didn't like this and I like this, I didn't like this, I like this, and you just remember it over time. And working in many different industries too, you get to see, like, I've worked in the aerospace world a lot too, and it's one of those that's very strict with what you can and can't do, and you get used to that, and then you go from this very strict environment to like just a regular job shop, and you start to cringe a little bit when you see what's going on. But it's not as important for a handrail than it is for like a jet engine part. So, and that's where with the way that I kind of overanalyze things, sometimes that can be a bad thing, because it is one of those, I've been told many times, like working at places where, just building a stainless frame or something, they're like, dude, it's not going to the moon, just weld it. But it's still, I'm going to take the time and at least acetone wipe down the tubes and make sure everything's nice and clean. Because then again, the next step where those parts were cleaned, it was twice as fast, because I took an extra 5 minutes, where other people, they just wanted to get it done and get on to the next job. But now down the road, you have people that are taking, 20, 30 minutes longer, or an hour, twice as longer to finish the part. So I try to look at the whole picture and do the best job that I can when it's on my bench.
Makes a lot of sense. Focus on the outcome. Let's talk more about the basics of welding 101. You covered a little bit of the stick, the MIG, the TIG. What else as an owner do I have to know about my welding department?
Well, I mean, it would be good for you to know the processes for sure, so you can walk out and see. I've had bosses before and owners before where they walk out, they couldn't tell you what this machine was or that machine is. Like, is this a MIG or is this a TIG? I don't know. You should know when you walk out. Like, hey, how's this MIG welder running, or how's this TIG running,
Mhm.
and just to be able to recognize the machines at least. And how's it going, and to be able to spot if you do see porosity in someone's weld or whatever, point it out and say, hey, what changed, what happened, what's going on, because we weren't getting this before, and just being a little bit aware of what's going on out there.
The inconsistency of the bead, is that something to ask questions about?
A lot of that has to do with either, I would say, probably the actual welder itself, like the operator,
Mhm.
because if they're consistent in their travel speed and all the welds should be consistent. Sometimes though, if the welder is normally consistent and the beads are starting to look kind of funny, like if it's MIG welding, there might be something wrong with the machine.
Hmm.
Like the liner inside the whip, or where the wire's coming through going to the gun,
Mhm.
there's a liner in there, and that can get dirty, and it can start to mess with how the wire's feeding out.
Hmm.
So those things need to be changed from time to time, and doing maintenance on your machines and blowing them out and making sure everything's good. But if you
What sort of
if you don't,
frequency for maintenance?
it all depends on your environment. If your shop is really dirty just from a lot of grinding dust, a lot of, you
Mhm.
know, dirty in general, it doesn't, I'm not necessarily like black grimy dirty, but just dirty in general, I would say probably at least minimum once a year, you
Mhm.
know, around this time of year, around Christmas or right before a holiday or something, just unplug all the machines, take them outside, blow them all out, take the panels off, just do some regular maintenance on them,
Hmm.
kind of look at all the guns, make
Mhm.
sure everything's in, ask questions. Are you having any issues with these machines? Anything we need to fix? And a lot of times the welders that are running these machines, they know the machine.
Mhm.
They know, like, hey, we need a new liner for this. And sometimes those companies, yeah, we're not going to spend the money on that. It's like, I'm telling you, if you put a new liner in here,
Mhm.
everything will be going nice. And, just checking that, make sure there's no gas leaks and all those things. They make huge differences in the long run.
Makes me think about, were we doing maintenance on our welding equipment at Rapid? And we were primarily welding in our sheet metal shop, not the machine
Mhm.
shop. What is a tight tolerance in welding?
That depends on what your industry is. And like, I've worked in like making boat tops,
Mhm.
the custom T tops for boats, where it was like a half inch from, as long as the top was from one side to the other side was a half of an inch, that was good.
Mhm.
And then my most recent job, we had to weld parts and hand grind them in, bench them into a dimension of plus or minus 2000s.
Really? Wow.
Yeah. So it ranges from crazy open to crazy tight. The sheet metal shop that I worked at many years ago, that was on average, could range from plus or minus 5 to 30. And that kind of goes back to how well your parts are formed. If they're formed within their tolerances, then your
Sure.
welds, it works better. But something you have to remember is when you weld something, the vast majority of the time is it's going to shrink. One trick that I always did to hold tolerances was I would tack the part up at its max tolerance plus maybe just a couple thousandths,
Hmm.
so that, if it was plus or minus 30, I actually had the full 60 thousandths to play in,
Mhm.
instead of tacking it right at the nominal number. Now I only have 30 because it's going to shrink. It's not going to grow. Most of the time, it won't grow.
That makes a lot of sense.
You just got to give yourself that wiggle room to play in.
When you get to grinding and then vibrating for finish, what are things you should think about there? And we talked about how the consistency of the weld affects grinding, but what other sort of things are considerations or should be thought about?
Well, this first thing that comes to mind would be for like prepping material for welding. You go ahead and grind it. A lot of people think that, well, I'm going to put a polished finish on it and use the maroon or blue Scotch Brite pads
Mm-hmm.
and grind those down, grind the edges and everything like that. And then you start noticing when you're welding that you're having issues with porosity or just little particles floating in the welds and all, especially on aluminum. Those pads actually have a wax or some type of a compound in them that will be transferred to the material. So
Hmm.
you don't want to use the maroon or blue Scotch Brite pads for prepping material. The coarser brown pads,
Mm-hmm.
those are good. You can use those pretty much all day long as you don't push on them too hard.
I'm going to interject here, Roy, and say, owners, this is why you want your welders to listen to Roy's podcast. You're probably not going to do this yourself, but anybody who's actually welding, these are little things that you just may not be aware of, and that's the easy knowledge that you get from a podcast or a YouTube video. So
Oh
sorry
yeah.
to interrupt there, but
No.
this is great.
That's one of those things where if you on my Instagram page recently, I posted a picture of a part that I welded up here, and it was just a sample
Mm-hmm.
weldment thing. It wasn't for a customer or anything, but I was prepping the material and I pushed the pad on purpose to try to transfer some of that contamination to the part
Mm.
and then welded over it, and you can see how and what it did
Hmm.
to that weld. So it's one of those, like, we're not lying when we say this happens. Here's proof of it. Even if you're using some of the abrasives on like aluminum, a softer material, it'll embed into the material as you're grinding it.
Mm.
You can't see it, but when you're welding along, you can see a little flare come out, and it's like, what was that? Well, it was a
Interesting.
little piece of zirconium or something from your grinding disc, or some type of oxide pad that was on there. So those are things that you need to keep in mind. If you're doing something that's like X-ray quality,
Mm-hmm.
you need to get all the way down to like using a carbide burr to clean up the edges, or a file that's dedicated to that material only,
Mm.
because you can get a lot of cross contamination issues that can be a big problem, especially with filler wires and different things. I see companies that have, speaking of grinding, like they'll have all their filler wire exposed underneath their table,
Mm-hmm.
and they're
Oh, wow.
grinding carbon steel. They're spraying carbon steel dust all over their stainless filler wire. And then
Sure.
they won't wipe down their stainless wire. They weld the parts, and now they have little rust specks
Mm-hmm.
coming through. It's because they transferred the carbon dust onto the weld. So that's, cross contamination is a big thing. And like in the aerospace industry, if you follow the code books, you're not allowed to have two different filler wires in your booth at one time. Even the same filler wire, just different diameters, that's a no-go. And then that's specifically for trying to eliminate cross contamination between the filler wires.
A lot of good tips and a lot of common sense here too. And dust may not seem like it's that big a deal, but
But
well,
it can be.
for example, I think you had showed what happens, or you've had experience what happens when you plate parts that have been contaminated. And in particular, black is sort of unforgiving in
Yeah.
not showing contamination.
Well, you had an episode recently about anodizing,
Mm-hmm.
and one of the things I was hoping it was going to be brought up was if you've ever anodized aluminum parts before and they were welded and they came back from anodizing and the welds were a different color, or a handrail that
Mm-hmm.
you ground the welds off, everything was perfectly smooth, and then you anodize it, now you can see that weld,
Mm-hmm.
plain as day. It's because the wrong filler wire was used. And that's where, you need to pay attention to what filler wire is being used down the road. Again, looking at the full picture. If it's being anodized, you have to use what's called 5356 filler wire.
Mm-hmm.
And most shops use 4043 filler wire, which it can be anodized, but it won't anodize the same color because I believe it has more silicon in it.
What other things do you have to think about if you are trying not to see the weld? Say you're welding up a box and you want the corners to be nice and smooth. Anything else, considerations?
For grinding itself, if you're all done with the welding process, everything and it's going to the grinding room, and all you're going to be doing for the rest of the time is grinding and painting after that. If you're not using a wax on your grinding pads, you're burning up your pads pretty fast. Beeswax works well. There's grinding waxes you can buy that'll make your grinding pads last a lot longer. And just the grinding pads themselves, if you spend the money and buy the really good grinding pads that cost a lot of money, they will last so much longer than a regular, cheap pad that, it's like, well, these are much cheaper, so I'm saving money. Again, are you in the long run when it takes, 5 of these pads where one of the more expensive ones will work just as well and, lasts longer? It's less fatigue on the actual grinder person and the machine, the grinder that they're using, but it's, again, don't cut corners.
The other part of welding where I don't think you want to cut corners is in your fixturing tools and jigs. Can you talk about that a little bit?
Oh yeah, that's one of the reasons that I'm not a big fan of robotic welding, was because the fixturing that they had was always terrible. And the robot's only going to weld, at least at the time. I'm sure now they've got much, much better robots. It's been probably 15 years since I've been around one, but the robot's only going to weld right where it's programmed to weld. If the part's not in the right spot on the fixture because the fixture moves or is, whatever, we were constantly going back and re-welding where the robot missed. And it's like, well, this is kind of defeating the purpose. And fixturing is very, very important. And like I said before, your part's going to shrink. So you have to consider how you're fixturing your parts. If you don't want to fixture on the inside of a part and weld all the outside, because then your fixture is just going to be stuck inside your part. And I've had that before where we told engineers, and it was all inside and lining stuff up, and we're like, you're not going to want us to weld that because you're going to have to machine that out. Nope, just weld it. Okay. They machined it out. But fixturing is very important, especially in production work. But take your time, do your fixtures right, make them beefy. Don't skimp on making these things, real chintzy, just get it done type of thing. It's like, well, if you're repeating these parts many, many times, I want to know that it came out of that fixture right. And not, well, we spent 15 minutes making this fixture and this one part was slightly off, and now we've got a semi truckload of bad parts, which I've dealt with before.
Sure. Well, what's your preferred clamping method technology, if I am actually asking a good question here?
Well, there's a lot of different types. It depends, again, what industry you're in, what type of work you're doing. Fixture tables are becoming much more popular nowadays. And that's like a tab and slot type of thing where you buy a bunch of plates that are laser cut and you just assemble the table. And now there's 5/8 holes every 2 inches on this table. And those holes have a gambit of different tooling that work with those, where you can clamp in the middle of the table very easily now. And there's several different types of clamps that you can use. Just the old school vice grip style clamps those are still really nice to have. There's newer, like kind of auto set clamps. I think Armor Tool makes them, where you don't really have to adjust the knob on the back anymore. So you can just go from fairly thick to fairly thin without adjusting at all. It just has a little tensioning screw. And that's really nice for good production work where, instead of having 15 clamps, you may only have to have 5. But with welding in general, clamps are your best friends. You'll never hear a welder say, I've got too many clamps. You can always have more, and multiples of every single kind, length and size. They're super nice to have. I've got probably 3 drawers full of clamps.
So it's sort of like a little Christmas present for your welder if you bring them some more
absolutely
clamps.
And with that, do yourself a favor and don't skimp out on them. Buy the ones that cost 20, 30, $40. They'll last a lifetime.
Hmm.
I've got clamps that my ex-father-in-law gave me when I was 18 years old. 21 years ago. I still have them today and they work great. And I remember working with guys that they would kind of laugh at me because I was going out and spending $30, $40 on a clamp. And they're like, dude, I went to Harbor Freight and I bought, 15 of these clamps for the same price as your two. But then all day they're sitting there struggling with them. They're getting stuck. They can't open them up easily. They're hurting their fingertips and all this stuff. And I'm over here just like, clip. So how is that now? And they probably lasted about 3 weeks and they threw them away. And I still have mine today.
The tabbing of parts, is that something that you, and I'm thinking more of the sheet metal world, is that something that you have found helpful if you are, for example, putting up the sides of a box together? Do you like to see tabs, or is there a better way in your mind to do it? Or do tabs help because shops have a variety of experience levels with their welders? Are tabs a good way to just provide consistency?
Yeah, tabs are a really good way to do that. The only thing that, if say you're doing like an outside corner joint and like an outside of a box and you have a tab in the middle or several tabs on a long run, the consistency is going to be slightly different because you're running over that tab. So that may affect things down the road. If you can make those tabs as small as possible, that is a big thing. If you're using, like Cleco clamps, those can be very handy in the welding world if it's assembled properly, and then you just have to go back in and fill in those Cleco clamp holes.
Anything else on fixturing tools and techniques?
Like I said, the toggle clamps that on a fixture where you can just pull the handle and the toggle comes down, those are really great to have on fixturing. And then they just are, some I've seen them just welded straight to the fixture, and then that just gets put on a shelf, and then you never have to worry about finding a clamp, setting it. It's just there. They're very handy to have. Just be sure to watch that little rubber boot on the end of them. It's gonna melt off.
Have some extras.
Oh yeah. Or just put a bolt on the end or something. But sometimes you have to watch, marring the material. And that's another thing, is depending on the outcome of the parts, you have to watch what type of clamps you're using. Because if you have like the big vice grip clamps with the swivel pads on them, and you clamp and then you see the person like drag it across so they can tack on the other side, well, now you got a nice circle, put it right on your part, and don't want that on everything.
I want to get into something a little philosophical. And if you think of, say, the toggle clamps, those have been around forever, right? Those are old. The clamping tables are relatively newer. And what things that are old, that are just people don't think about in welding, should be rethought or approached differently? Where is welding not in the 21st century?
It's a pretty deep question, I guess.
Yeah. Where I'm going with that, as an owner, if I am looking globally at the welding department and I'm thinking about where should I make investments? And
all right,
yes, the toggle clamps work, but it's either not giving me the accuracy or it's not the most efficient way. And I'm picking on toggle clamps here, but just globally, all the different things, what things that are old that we should just think about, and maybe it's something that's not quite here yet, but you've seen glimpses of in the future.
Well, first thing, when thinking about that question, the first thing that popped in my mind was the physical machines themselves. Like if you have a welding department already and you've got machines that are like an older Miller Synchrowave 200 or 300 or something, and they're working great, why change it? But the technology has changed so much with machinery now, like with the inverter welders, that if say you're welding aluminum with an older Synchrowave machine and you have the money to invest in new machines, if you were to buy, say, like a Dynasty or a Fronius Magic Wave or a Lincoln, I think they're an Aspect machines, your production will go way up the speed of the welding will go way up because the older machines are set at like 60 hertz, which is what comes out of the wall. And
Mhm.
that's kind of a slower, the puddle's kind of sluggish. You can only go so fast, but with the newer inverter machines, you can adjust the frequencies
Mhm.
and you can really fine tune what you're doing. And you can really, just lay a little micro bead down the side of your part and get moving. And the power consumption alone of these machines are where like the older synchro waves, you have to run them on like a 100 amp breaker. And
Mhm.
if you're running a small sheet metal shop where you rarely go over 100 amps, you can get a smaller 200 amp machine, run it off of 110,
Mm.
and your power consumption in the building will drop drastically.
So this is a great example because it's so hard as an owner. Something's working,
Yeah.
and you want me to, let's say, worst case, just scrap it. Maybe you can get some dollars for it, but let's say you just have to scrap it. But you want me to, what do one of these new machines cost, the ones that you were naming?
You can get it for a couple $1,000 up to, $6,000
Okay.
for a
So,
really, really fancy.
so not huge money, but at the same time, let's say it's $5,000,
Mhm.
and you're going to think about that as an owner, spending $5,000 for a new welder that, when I have a welding machine that works perfectly fine, or at least in your mind you do. So do you know of any tools out there, spreadsheets online or anything? Have you guys gone into that on your podcast to say, here's the cost justification, the savings in power, the decrease or the amount of the increase in inches per minute or per hour of weld, so that you can do a cost justification and show, hey, in 6 months I am making money with this new machine. By spending money, I'm making money. So long
Yeah,
question, anything out there that you know?
that I don't know off the top of my head. I wouldn't know. I know if you probably go to a Miller site, they probably have that information, or Lincoln or Fronius.
Hmm.
They probably have all that somewhere in there. Or if you talk to some of the salesmen.
Well, when we post this, maybe one of the companies who make the machines can post a link to their website to a calculator, because this is the type of thing. And I always loved investing in new equipment because I thought that even a welder can be computerized pretty simply to do the types of things that you were talking about, and
Oh, yeah.
so many benefits there.
Well, and then also too, with a lot of the newer welders, they have memory settings on
Hmm.
them. So you
Yep.
can have in your job routers, you can have the settings preset where
Hmm.
you just pull it up on that router. It's like memory 3 or memory 4 or 5, whatever.
Hmm.
And even some of them, like the Fronius machines, they can set them up to where they're on a network,
Ah,
and you can have pretty much unlimited settings, I believe.
sure.
And even if you're running a company that has, say, 50 booths on it, they've got a thing, I think it's called the Weld Cube, that monitors all of the machines that are on that system. And if someone goes outside of the parameters of the job that it's supposed to be, it'll let you know.
Hmm.
So kind of, it can streamline things just with the technology and the machines themselves.
Yeah. Oh,
And
wish I could invest in a new welding machine.
well, and one company I worked at here in Ohio was an aerospace company. They had Syncrowave, I think they were 350s, and the most that that company ever welded at was like 75 amps, 80 amps at most.
Hmm.
And they had machines that would go up to 350 amps. And these were big power sucking dinosaurs. And I'm like, why don't you guys invest in like a Miller Dynasty 200 or a 210 or something? They'll fit up underneath the table.
Hmm.
You can run it off of 110 or 220.
That's another example.
Just the
Space, just space. Space costs money.
That's what I was saying. Just the footprint of the machine alone in that shop, you could probably easily have added 3 more booths
Hmm. Yeah.
and not change the actual footing or the foot space of the welding department, but the booths themselves would have been a little bit smaller, which would have been fine at that place. Some places it's not ideal to have a small booth, but
Right. What other new things that you've seen, materials, I don't know, anything else that shop owners or someone in charge of a welding area should be considering?
Well, one of the newer things that would be, I don't want to say it would be really hard to explain to an owner of a company, but is the tooling that you can buy. That if you're on Instagram, look up uh, Fireball Tools
Hmm.
and Genuine Metal Fab. They make fabrication tools that make your job so much faster, so much easier. You could just clamp right to these tools and
Hmm.
you've got a square corner, you tack it, you're good to go. They work with the fixture tables.
Hmm.
They're on Instagram. There's a huge welding community on there, and a lot of people are actual welders that are making their own tooling because it's like, what do I need to make my job better and make my job faster and easier? And a
Hmm.
lot of them are small business owners, so they want to, make things go much more profitable for them.
Hmm.
So they've come up with their own tools, and investing in those tools, they're not super cheap, but looking back at the frames that I've built in the past and the different things that I've done in the past, I wish I had these tools. So it's like Fireball squares and Genuine Metal Fab square, they're awesome, amazing tools.
So one of the things that I always encouraged was to not question the folks on the shop floor who wanted to try something. And typically it's relatively low dollars to try something. And so I would encourage other shop owners, throw a few dollars out there. Worst case, if it doesn't work, put it on eBay and recapture some
Hmm.
of your money. But try some of these different things, because that's the way that you consistently improve the efficiency, productivity of your shop. And also you make the team members a lot happier because they are involved in this whole thing, and they're definitely going to come up with some things that make their life better. And if
Oh,
their lives are
absolutely.
better, they're going to be happy. And if they're happy, you're happy. So uh,
Absolutely.
I want to jump to quoting and estimating. And when you are estimating a part, and I'm going to specifically go to sheet metal here. What things do you really have to pay attention to when you're estimating a sheet metal part that's going to be either tack welded or continuous weld? And let's assume that we're going to grind and vibrate as well.
Well, a lot of it, like you kind of mentioned it before when we first started with this, where the welding end of it always ends up being kind of like slightly an afterthought, like just weld it, just get it done, just weld
Hmm.
it. And they never consider the time that all the prep work and clamping and getting it all set right. And whenever you're doing your estimating, a lot of shops I've worked at in the past, they've had just like a calculator that they use. It's like, well, our shop rate is this much for this many inches of weld. And it's like, well,
Right.
that works and it doesn't work. Like if you're welding something that's a half inch thick, you can't use the same calculator as something that's 30 thousandths thick.
Hmm.
But a lot of times they do it. They're like, well, you get 4 minutes to weld this part. And it's like, it's going to take 3 minutes to heat up.
Hmm.
But, so, just
Ah.
you have to look at every single step
So wait,
just the same as you would.
you said something that for you is common knowledge, but for me in estimating, when you say heat up,
Yeah,
the thicker the material, the longer it takes to heat up so it will
yep,
accept the weld. Is that what I'm hearing?
absolutely. And depending on the material, like say if you're welding aluminum,
Hmm.
even thin aluminum, say you're in Florida and it's a humid day,
Hmm.
your aluminum's going to weld different because aluminum's porous and it absorbs the humidity in the air.
Hmm.
So if you preheat the material ever so slightly, you'll see moisture coming out of the material.
Huh.
So that helps your weld better, less porosity, but it takes a couple minutes. So you're going to
Hmm.
have to, why'd these take so long? Well, I had to preheat them. Well, we didn't account for preheating. Okay.
Yeah, it's a thin
I've,
material. What do you mean you have to preheat it? Well, it's
yeah, I've worked in one place where we did it was a half inch piece of aluminum that was being welded to an eighth of an inch piece of aluminum.
Mhm.
And I jokingly said, why don't we get just a, regular oven, plug it in over here, throw the parts in there
Mhm.
and preheat your part. Just let it sit it on broil,
Right.
set them at 500 degrees. They're only in there for, 15, 20 minutes or something. It's not going to affect them. It's
Mm.
just preheating them. And preheat can really, really speed things up. And then sometimes too, if you've got a hot plate or whatever, you can set your part on it
Hmm.
while it's preheating while you're welding the next part. And so
Interesting.
that it can be a part of the process. And but if it's something that you skipped in the estimating of it,
Right.
you know, you can sit there with the machine and just let the actual arc preheat the part and just, sit there and sit there and sit there until the puddle's ready to go. And then you can start welding, or you can preheat the part while you're working on the next one and just kind of have a little bit of a system going. But you have to think about that before you start.
I like that. Any other rules of thumb or suggestions to think about when you're estimating?
Just like I said before, every single step, you know, consider prepping the material. Don't just consider, well, it's bent, ready to go, so all you got to do is clamp it and weld it. Well, think about how much time is it going to take to wipe down the parts with acetone,
Mhm.
or can they be chemically cleaned before, if you have that option
Mhm.
in your shop? Do the edges need to be ground off? Would it be faster to grind the edges before we bent the parts? Was
Mm.
one of the things I'm like, how much faster and easier it would be to grind the edges of this before we bend it all up, and now we have to like kind of pry it apart to grind that edge.
Putting it in the time saver, does that accomplish what you were asking for?
No, it's actually the side of the
Okay.
material that's being welded, like on an outside
Yep.
corner
Yep.
joint, the
Yep.
two sides.
Gotcha. Gotcha. Okay. And are there any gotchas in the estimating process that might cause you to lose money that people don't commonly think of?
Well, it goes back to the prep work, where if you didn't grind that burnt edge off,
Mhm.
and now it goes to the grinding department, and now you've got porosity, you got to come back and refill those in, grind them
Mhm.
out, refill it in, bring it back. There's a lot of back and forth. You don't want that.
Right. Do it once.
Yeah, I've said it 100 times in different shops that I've worked at, where it's funny we don't have time to do it
Mhm.
right the first time, but we got time to do it twice.
Right. Definitely heard that before. A little bit different question from a designer's perspective. When I'm designing a part that needs to, or let's say several different parts that need to be fastened together, or I guess it could be even the sides of a box or something. Why do I want to weld when I could just fasten with PEM hardware? Because it would cost a lot less to do that.
I think it would be the outcome of the part itself. Some parts would benefit more from a rivet or pen bolts or pen nuts or whatever you want to call them. It really is the outcome of the part. Or spot welding, it might be better than a full seam weld if
Hmm.
you have that capability.
Do you see, from your perspective, parts that come through and you're saying, why are they welding this? They should be riveting or mechanically fastening or spot welding.
A few pieces that have come across my bench in the past where it's like, this would be a lot better if we spot welded this. Why are we, TIG welding this with this little tiny
Hmm.
part on here? We could just, zap on there and it'd be good to go. But in general, most of the time it's, just everything's pretty good. A lot of times the things that we run into issues on the floor are engineers or designers that design a part that needs to be welded, and the physical area that needs to be welded is very difficult to get to,
Hmm.
and they don't consider that, and it's like, well, just get down there. It's like,
Well, can you
okay.
describe that a little more? What makes it physically difficult to weld, or what are there common things that come up over and over again that for
Well,
physically
like
difficult?
if you have a really tight area to get into, like there's mating parts that are really close together, and you
Mm.
have to get to the joint. So that's when you start getting the mirrors out and you got to weld behind something, and
Oh,
you
wow.
can't figure you can't see what you're doing,
Hmm.
or it's way down into a trough of some kind, and you have to weld a full seam weld. And it's like my torch doesn't even fit down here. So now I got to like stick my tungsten, which is comes out of the TIG torch,
Mm-hmm.
and stick that way down. But you can only go so far before you start losing your gas coverage. So you have to like figure out and create some like dams of some kind to hold your argon in there, which shields the gas or shields the weld while it's at a high elevated temperature. And it's one of those like, well, can you do it? It's like, yeah, but it's going to be a pain. You know, they do make different torches for different applications. Like CK Worldwide is a big torch company for TIG torches, and they have a whole gambit of different types of torches that you can buy for getting into really small areas, getting into, you know, if you have something that you're welding and it's like super super hot and you're burning up torches left and right, it's like, well, just get a bigger torch. They
Mm.
make them up to, you know, 500 amps or so, but you're not going to use that big huge torch on a little tiny part. I mean, you can, but it, you know, it's kind of like welding with a baseball bat in your hand.
Sure.
Yeah,
Okay.
so you can tailor your equipment to the jobs that you're working on.
This has been super helpful, and I loved getting into some of these specifics for the owners to think about. I want to talk about the people side a little bit before we conclude. And the thing that I'll give an example of how do you hire a welder and have them demonstrate welding competency. And the first employee at Rapid Sheet Metal, a guy named Scott Reynolds, great guy, helped our shop in so many ways over the years. One of the things that he had in his toolbox was the butt ends of two soda cans welded together. And I loved it. Like, wow, how do you do that without the cans, putting a hole in them and melting them and that. And so I used to show folks when they'd come in through the shop, and finally he said, Jay, please don't show them that. I can do that, but we don't want to be doing that sort of welding every
Yeah.
day. But that was a way of demonstrating welding competency. If you are bringing someone on or helping a shop hire a welder, what's your favorite way or ways for someone to demonstrate that welding competency?
In general, there's always a weld test that you do, and it depends on the industry you're in. And you want to use you want to use the most common materials that you're welding in
Hmm.
your shop. So if you're mostly welding aluminum, obviously you don't want to test them on steel.
Hmm.
So tailor your tests to what you're going to be welding. And some places it's just butting two plates together, welding it, or a
Hmm.
fillet weld, or, you know, an outside corner joint or something. Again, it's just to prove, you know,
Hmm.
what you put on your resume doesn't always match what you can actually do out on the floor. So
Hmm.
it's kind of it just lets you know. But a butt weld, a fillet weld, maybe if you do a lot of round parts, do something on something going around a piece of pipe or something like that. Sometimes, you know, for me personally, if I was going to be hiring someone for Crummy Welding, I would probably put them through a big gambit of different parts just because I want to see what you can do.
Hmm.
And I know, can I trust you on this? You know, give you a turntable part, maybe even have, if I want to get really picky, you know, have couple different levels. Like, this is just a butt weld and a fillet weld just gets you in the door.
Hmm.
And then, okay, now we're gonna have a second test that's a little bit harder and see if you can pass that now too. I've had it before, you know, just recently I applied at a job and they were really surprised that I didn't need a second set of material. I was able to weld the parts out on the first one. It's like, usually only get one.
Have you guys done a podcast on that topic?
Weld tests.
Well, just how do you hire and show weld competency? I think that would be a
um
great topic for
I don't know if we
both
did
sides.
one. I'm not sure if we did one on hiring welders, but I know way, way, way back at the beginning. And if you listen to it, I apologize for the audio quality because we didn't know exactly what we were
Yeah.
doing. But I believe it's episode maybe 3 or 4. it's taking weld tests, because we were kind of, jokingly saying it's like, well, we're starting this new venture, basically a new job, and what's the first thing you do at a job is you take a weld test.
Hmm.
So, and with the weld tests too, if you're going for certified welding, you take your weld test to come in the door, and then you take a whole gambit of different tests once you've been hired
Hmm. Do
for
certi-
whatever certifications are.
do certifications matter?
Depends on the material, or depends on the industry you're in and the jobs you're working on. Sometimes it's extremely important and other times it's not. Again, if you're welding on an aircraft part, you're going to need certifications.
Hmm.
If you're welding on a gate or a handrail,
Right.
probably not. But a big misconception that is in the welding world, and I think it's just the way that it's set up, is once you're certified, you're not certified for life.
Mm.
You're not, the certifications don't transfer from company to company. They may be able to if it's written right in the way that they have their paperwork set up, but majority of the time, if you're certified at one company, and even if it's the exact same certification and you go to a different company, you still have to retest and recertify under their procedures. It
Gotcha.
doesn't transfer. So that's when a company's asking you, I need a certified welder. It's like, well, no, that's not how it works. You have to
Hmm.
certify the welder under your procedures for your company.
Gotcha.
You can get someone that can be certified, or
Right.
someone that's
Right.
had
Right.
certifications.
Let's flip it around. Someone who wants to get into welding, what would you suggest to them? Where can they get experience? Where can they learn?
Well, if you just want to get into it and try it and see what happens and see if you like it, there's a lot of community colleges around. There's, trade schools and places that sometimes they offer like just a week course,
Hmm.
a week, or 40 hours or something like that, and just to dip your toe in the water to see if it's something you'd be interested in. At the same time, if you want to invest in some money on your own, some of these economy style TIG welders you can buy on Amazon for, $800,
Hmm.
and they're actually pretty good. And then go on YouTube, the whole YouTube U thing,
Right.
and start learning that way. It is a very difficult trade or difficult skill to learn on your own, because you don't know if you're making mistakes
Hmm.
and learning bad habits and things along those lines. And it you can get very frustrated with it really quick and really easily. So having someone local to look over your shoulder and tell you, and well, if you just, lift up a little bit on the torch and go a little bit quicker, and everything starts smoothing out a little bit better. Again, Instagram is a great place
Hmm.
to meet people, talk to people. There's a great community on there. You can ask questions, people will help you. There's not a lot of shaming. If you post something and say, hey, this is my first weld I've ever done, I really would like to learn how to do this, can anyone help me?
Hmm.
And someone will probably reach out and be willing to help you. Or, a lot of times, some people, again, on Instagram, like myself, we offer classes in our own shops. So that's a one-on-one, sometimes
Mm.
1 day or 2 day class, just to give you a good base knowledge of what's going on, how to, sharpen your tungsten, how to do these different things. And then, kind of take that knowledge and build off of that. But at least it gives you a base to work off of, instead of just being completely, I don't know what's going on, no clue what's happening here.
Sure. Well, I want to share, if I could, a way that we were able to celebrate welding at Rapid Sheet Metal. And we had a welder who came to me. His name is Corey Stairs. And he had an idea about creating an artistic weldment to be displayed outside on the front lawn of Rapid. And the concept was really cool. One of our core values was enjoy the journey. And he brought to me a scaled down model of the weldment, the sculpture that he wanted to create. And he said, this is called the journey. And I want people to drive by Rapid and enjoy the journey. So he said, I'll donate all the time to do this if Rapid can donate the materials. And we did. And we ended up with about an 8-foot high sculpture, which we poured a cement pad in the front. We put some solar powered lights on it, and it was so cool to have this really unique welded sculpture out there for everybody to enjoy as they drove by. And Corey did such a super job. There were a lot of other folks in the company who helped him out. And I just thought, what a great way to bring the art side of welding outside of a strictly mechanical environment. So I don't know if how much you get involved in the artistic community, but if there are shop owners who have a welder who would like to do something like that, I really encourage you to support them and even sort of seek that out, because it was a really fun project that brought Rapid together.
That would be really cool. Yeah, I wish a lot of places I worked would have been willing to do something like that. That's really awesome of you to have done that.
I just was so excited that he wanted to express one of our core values like that. And so, yeah, it was fun all the way around. Well, Roy, this has really been awesome. I have gained a much better appreciation of welding and what goes into it, and always enjoyed the skill our welders exhibited, but I didn't really have the background to fully think about how to improve the welding area for both them and the customers. So thanks for providing tons of great tips and thoughts about how to look at welding from that owner's or manager's perspective. Great work with your podcasts. Let's sort of end it with, is there anything we missed about welding that you want to get out there and share with this audience?
Besides, just take the time and do it right. Don't skip steps. Don't make welding be just another step in the process, like, just weld it. Like you said, it's its own art form, it's its own thing. You can't change the speeds and feeds of a machine or you'll get chatter or bad, you'll destroy your tools. It's the same thing as weld. You got to give it its time to do it right the first time. And like I said, it's always been where I've worked, and in my experience, it's always been just kind of rush it through the weld department and get it out. It's like, well, it takes its own time, it takes its own thing, give it its own time, and it'll pay off in the long run if you do it right the first time.
Couldn't agree more. So thank you for ending with that. How can people reach you and also listen to your podcast?
Well, with the podcast, it's the Welding Tips and Tricks podcast, and you can probably find it anywhere that you're listening to this podcast, on any platforms. We have Welding Tips and Tricks podcast.com. And if you want to reach me, you can find me at crummywelding.com or on Instagram at Crummy Welding. And if you want to learn a lot about welding, I would strongly recommend looking up Welding Tips and Tricks on YouTube. And there's hundreds and hundreds of weld videos and tutorials and things like that that are very, very useful and very, very helpful to anybody that wants to learn anything about welding.
That's awesome. I'm so excited. Thank you again, Roy, for your time. And for the listeners, how about an action item of taking a stroll down to your welding department and looking around, and think about what you see from the lens of this conversation, and then engage with your welding team. What little things could you let them implement that would make a difference? Until next time, keep those spindles turning, those lasers cutting, and those torches lit. Have a fantastic day.